Welcome to the Daily MBA, where business wisdom is served fresh and fast, straight from one of the top MBA programs in the world. I'll give you summaries of my lectures and readings, as well as the most important insights gained from an MBA, so you can apply all of this knowledge in every business. Let's get started. In today's episode, I'm going to start dedicating it only for oligopolies. And I decided to do this because oligopolies make up a lot of today's market, because the definition of an oligopoly means that there are only a few firms on that market. And it states that there is a market power just as a monopoly, but you do have rivals. So price will be determined by those rivals, and also the output level would be the strategic decision that you want to plan with these rivals. For concentrating in the models that exist, we're going to simplify it into duopoly models, which means that there are only two firms and where the total output would equal the output of firm 1 plus the outcome of firm 2. So this is just a simplification, but oligopolies would be a few firms. It could be up to 3 firms, 4 firms. You can start adding them up until it starts behaving a little bit like monopolistic competition. But the truth is, oligopoly will still have lots of market power. And this is seen in today's world in most of the big firms. Let's say Visa, MasterCard, American Express. Those are big oligopolies that are just acquiring all the competition out there. And they're not going to kick each other out. They're playing by their rules. So what we're going to see is that there are 3 models that are studying. And the first model is Cournot. Cournot was a French economist, and he created this model that places oligopolies between the monopoly and the perfect competition, just as I was telling you. But he's going to state that both firms will choose the output levels at the same time. So, between this, firms are caring about their half of the market. They don't care about anything else, but what they try to do is optimize their amount. So, the total output produced will be even bigger than the one in monopoly, and this will also lead to an output of a higher price. This is going to be the result of this model. So in the Cournot equilibrium, what we usually see is that we have a firm that's usually considered firm 1 with a demand curve, but we also see a firm 2 with another demand curve, and what has to intersect is the perfect equilibrium of these 2 firms. So the way for solving for this equilibrium now mathematically, now that you know the logics behind it, is that we're going to set first an inverse market demand. An inverse market demand means that you have your demand equation, but you're going to clear it up for P and leave it all in terms of P. Let's say P equals something else. After you already have that, you're going to get the marginal revenue and the marginal cost for each firm. Because remember, what I've been telling you always is that our equilibrium point will be when these 2 are equal. But if you don't have them, you'll have to get them. And in the previous episode, I told you how you get the marginal revenue curve. This one is going to be just as the demand, but twice as steep. So it has the same intersect, but the slope is going to be multiplied times 2. The marginal cost will usually be given to you because these are the costs that a firm is incurring into. But you have to get them and put them into a set of equations where the quantity of each firms are correlated. Because we already saw that, for example, a marginal revenue of firm 1 may include the quantity of 2, as the total output of the market is determined by adding quantity 1 and quantity 2. After that, you already have your marginal revenue and your marginal cost, and you're going to equal this 2 into getting a reaction function. And reaction function sounds very elaborate, but it's basically just saying marginal revenue equals marginal cost. And if you've been listening to my previous episodes, this means it's always the balance point. Firms want to produce at this output level, and they want to sell at the price of this output level. Marginal revenue equals marginal cost. After you solve the functions, you can get the quantity of firm 1 and the quantity of firm 2, and from that you can find out the total quantity which is produced. just adding up the quantities of each of the individual firms, and that will give you the price. So what we see over here, it's just a bit more in the middle of monopolies and perfect competition, and that would be everything about Cournot. But now there's another market equilibrium that could be reached, and this one's called Stackelberg. Stackelberg is also considering two firms that are changing their quantities, but here somebody moves first. The order matters. And the leader that produces first will have a first mover advantage. So these two models can be used depending on the industry that you believe. For example, Stackelberg may be very useful for concrete factories, where you get a very big company that's going to be the leader and speed is what matters. The leader, in this case, will choose the level of output to maximize the profits given the knowledge of the follower's reaction. Stackelberg's leader will produce the same level of output that a monopolistic would, and the second firm then will produce the half of that amount, so the total market output will be bigger than monopoly, but the leader will behave very much like a monopoly. So this is very interesting, and let's consider the logic behind it. You are the leader, and you have another company that's in the same industry with a similar product. I decide to produce more. When you produce more, if you remember, price will go down. If price goes down, then my rival that's over there won't want to produce more. He doesn't have any incentive because the price is down already. So he'll probably produce less than what he originally wanted. If he produces less output than what he wanted, this may even push my price up because I was expecting more. So the less output from the rival will push the price up back again and will incentivize me, or the leader, to produce even more. So it becomes like a cycle where all the time the leader will get the benefit. And he might even want to get this power and crush out the other person, but usually he doesn't need to because the market dynamics are already giving him enough power. And this will mean that he's producing a higher quantity because he's being incentivized to produce more and more. The steps for solving this equilibrium will be divided in two parts. First, we have to find the follower's reaction function. And this one, reaction function, I just mentioned it with Cournot because you have to find the reaction same method. But if you want to skip that, I have a little tip, because I have an equation that's all pretty for you to already find the follower's reaction function. And this means that the quantity of the second company, which will be the rival, not the leader, is going to be the intercept minus the costs. In this case, it may be marginal costs. And all of this will be divided by 2 times the multiple that is in the demand curve. So the multiple that's in there for quantity. Let's say in my head, my demand equation, I'll put numbers so this sounds a little bit more simple. My demand equation is going to be P equals 20 minus Q1 minus Q2, let's say. So I'm not multiplying any of these variables of Q for any multiple, just to make it simpler. But my intercept was 20. So we're going to start the equation by taking 20. Then I'll subtract the costs, which are somewhere else. Someone gave them to me, so let's assume it's 5. So 20 minus 5, that's going to be 15. And then we'll divide that by the multiple that was multiplying the quantity. In this case, I chose there not to be a multiple because I said just quantity 1 plus quantity 2. If I had said quantity 1 plus 2 times quantity 2, I would have to multiply 2 times the 2 that was multiplying that equation. In this case, it would just be, let's go back again, 20 minus 5 over 2 times 1. So that would be the reaction function. And now that you have the quantity for 2, you can substitute it into the demand function. And this would be the second step. Now that you have all of the quantities, you can set the marginal revenue equals the marginal cost for the leader to maximize the profit. And then you just solve for Q1 and Q2. So it's going to be similar to the one we just did, but the reaction function will only be for the follower, not for the leader. Now, there's a third model that I wanted to study, and it's called Bertrand. But Bertrand is not very good because in this one, he's trying to say that both firms are competing in prices for homogeneous products. And the perfect example for this would be gas stations. So the firms will choose to fight over price instead of quantity. If you recall the other two models, they were fighting over the quantity more. Now they'll fight for the price. And they will engage in price war, undercutting each other when possible for any price that's bigger than the average cost. Because any firm that has prices bigger than the average cost will be incentivized to lower in order to get a bit more of that market share. And they will lower it until you can't lower it even more. And so all of the firms will be stuck in that price where it's zero profit and the price will equal the marginal cost. A similar logic to this may be Zeno's dichotomy paradox. I don't know if you've heard it before, but this one's very old. It's about philosophy. And it says that for getting to a place, then you should start getting halfway there. And after you've done halfway of the path, you should also go half of the remaining way. After you've gone that half, you should also do half of what you have left. If you keep doing this by halves, there will always be some distance remaining, and the goal won't ever be reached. This is the logic, basically, behind this Bertrand model. Firms will keep pushing the price until they can't even get more. When we're comparing models, we should consider that the market output of Bertrand is the biggest, because they're both lowering their prices to give more to the consumers. The second highest market output would be Stackelberg, where you have the leader and the follower, and the third one would be Cournot, where they are just combining a monopoly model with the perfect competition model. But now, when we're looking at the profits created, Stackelberg leader is the one that wins, followed by Cournot, and then by the Stackelberg follower. The last ones in profits would definitely be Bertrand because they engaged in price wars and they're in zero profit now. I hope this was useful and that it helped you set up your mind around all of these different models of oligopolies, that they are very common in today's world and you can see them in most types of firms. Solving for these equations may sound complicated, but I'm going to upload a summary of all those formulas so you can check it out in the comments. I'll see you next week.